Okay. In the previous lecture, I have talked about some of the blocks. Okay, some of the important blocks. I have told you what are the format of the input array, what is the format of the state array, which is also called as intermediate results. That is in the form of S0.0, S0.1. Okay, I have told you what is the meaning of S0.0. 0.0 means zeroth byte of zeroth word. Okay, and if I am taking S2, 1, 2 stands for second byte of the first word. Okay, so in total we have 4 words. And in the last I have told you the output array. Okay, output array. So output array and the input array are most probably the format is same: in0, in1, in2, in3. And output arrow is out0, out1, out2, and out3. Okay, and regarding the key also I have told you it is also k0, k1, k2, k3. Okay, so we have to understand that first column is first word, second column is second word, third column is third row, third word, and fourth column is fourth word. Okay, similarly you know that we have total 40 round, total we have 10 rounds, and each round we are using 4 words. So total I am having 40 words plus 4 pre-round words, 4 pre-round words. So before I'm using 4 words, that is called as a 4 pre-round words. So in total, I'm having 44 words. So how do I write the words? W0, W1, W2, W3. So in this W0, W1, W2, and W3, they are the 4 pre-round words. Okay. So that is called as a key expansion. Key expansion. Okay. Then we have seen the substitution bytes. I have told you in the substitution bytes. So I'm going to revise it once again. So in the substitution bytes, मैंने बताया था कि if you have as 0, 0. So similarly, if I'm drawing the format, this is called as a state format. Okay, state format called as S because it is for S block, S box. Substitution byte, substitution byte. So if it is S0, 0, it will be S0, 1. Sorry, it is 1, 0. Then it is S2, 0, S3, 0. So zeroth word of zeroth byte of zeroth word, first byte of zeroth word, second byte of zeroth word, third byte of zeroth word. Okay, and so forth. So total we have 4 by 4. We have 4 by 4. Okay, 4 by 4. I have told you I am saying this as a 1 byte, second byte, third byte, fourth byte. So you know that 1 byte consists of 8 bits. If I'm taking 8 bits, I have given an example. Suppose my 8 bits are 0, 0, 1, 0, 1, 1, 0, 0. If this is the example I have taken, so you have to consider the first 4 bits as a row numbers, first 4 bits as a row numbers, and last 4 bits as a column number, Okay, so when you consider these 4 bits as a row number, you know that 4 bits consists 4 bits will give you 2 to the power of 4, that is 16 rows. So your rows will be from 0 to 15, and your 4 bits, last 4 bits will represent the column number. Here also 4 bits will give you the combination of 16 combinations. So again it is from 0, 1, 2, to 15, and this is called as table of value. This is called as table of value. This is called as table of value for this S box. So for example, if it is 0, 0, 1, 0, 1, 1, 0, 0, if this is an example, you have to substitute these 8 bits into 8 bits, because you know that input to the substitution box is 128 and the output is also 128. Am I right? So input to the substitution box is 128, output also 128. So we are not going to reduce the bits. The bits will be the same. But only thing is that we have to find the element corresponding to these 4 bits and the last 4 bits. So if it is 0, 0, 1, 0, it will be this corresponds to decimal number 2, and 0, 0, 1, 1, that is 1, 2, 4, 8. So it is 12. So 12 represents the column number. So you have to identify where is second row. So second row, so this 0, 1, 2. So second row, we have to identify that element, second row and 12th column. Suppose 12th column is here. So you have to find the 12th column. So second row and 12th column, wherever it meets, and that element, suppose for that, for example, that element is suppose 9. So we have to convert this line decimal number 9 into binaries, ones and zeros. So it is like 0000 1001 1001. So I have substituted 00101100 to triple 4 times 0 1001. So this 8-bit number which was 00101100, this has been substituted into 00001001. Okay, so what could be the resultant vector or resultant array? That resultant array will be again 4 by 4. Again it will be 4 by 4. Again it will be 4 by 4. So whatever was here, that will be substituted here. That will be substituted here. Okay, so initially it was 00101100. Now it will be 00001001, which corresponds to decimal number 9. As we have done for this first byte, do it for this one, and this one, and substitute at their corresponding positions. So similarly, you have to do for 16 cells, and you have to replace these cells with these particular values. And where you will get these values? From the value of table. So if I ask you what is the size of that particular हेलो, यस बोर्ड दिख रहा है अभी?
यस सर, यस सर।
अभी ये रिकॉर्डिंग है, ये स्टॉप करके फिर से स्टार्ट करूँ या कंटिन्यूशन में रहने दूँ?
सर रिकॉर्डिंग दिखा रहे तो वो मीटिंग पूरा रिकॉर्ड हो रहा है।
तो वो जो पावर कट हो गया था वो?
नहीं सर, वो मीटिंग तो रिकॉर्ड हो रहा था ना, तो आपने सिर्फ लीव किया है, लेकिन मीटिंग स्टिल ऑन था।
तो ठीक है, तो स्टॉप करके रिकॉर्डिंग फिर से नहीं करूँ ना?
नहीं सर।
ओके। So this was your state array, that is S. Now this becomes state array. Write down state array S dash. I have already told you intermediate results which are formed. They are called as a state array. They are called as a state array. Okay. So this is state array. This is state array called as S because this is for substitution byte S box. And that afterwards converting into this particular format, this is also state array because this is the intermediate result. So this is called as a resultant state array called as S dash. You can just write down state array S dash. State array S dash. Okay. Now what, after getting all the 16 cells, after getting all the 16 cells, now can you see this is also 128 bits and this is also 128 bits. This is also 128 bits. Okay. So this was input to the S box substitution byte and this is the output of the substitution byte. Okay. Now this becomes, this particular state array S dash becomes the input to the shift rows. Now we are going to understand the shift rows. That is your second block. Please refer to the previous block diagram. We have done with the substitution byte S box. Now we are going to understand shift rows. Bracket में आपने लिखा था circular right shift operation. Circular right shift operation. Okay. Now this becomes state array S dash becomes input to the substitution rows. And again the output of the shift rows is also 128 bits. 128 bits. So we are going to understand what is shift rows. What is shift rows? What is shift rows? Okay. Now write down the heading as shift rows. Shift rows. Shift rows. कुछ doubt है तो just unmute yourself and ask me the questions if you have any queries, any doubt. या कौन सा any particular thing you have not understood. Okay. Now we are going to understand the shift rows. So please write down shift rows. In bracket it is called as a circular right shift. जो already आपने लिखा है. Circular right shift operation. Circular right shift operation. This is important. Try to understand what is happening in this particular block. Okay. Now here I am going to write down the input one. Input to this. Again, you know this is S dash. हमने जो वहां पे बनाया था that is a state array called as S dash. उसका इनपुट था, मैंने S लिखा था उसमें. अभी मैं that array the input I will write down S dash. S dash. So S dash it will be 0,0. Then it will be S dash 1,0. Then it is S dash 2,0. And the last one is S dash, that is 3,0. Again the same thing, 0th byte of 0th word, first byte of 0th word, second byte of 0th word, third byte of 0th word. Similarly, I have to draw for the remaining. I have to draw for the remaining. Okay. So I won't be writing down each and every cell. You can write down. Okay. What I will do, otherwise I will write it down because this is important. You should know, you should be able to know this. All of you draw it fast. S dash 1,1. S dash. This is sorry. S dash 0, yes, it is 0,1. This is S dash 1,1. S dash 2,1. S dash 3,1. This is S dash. It is 0,2. S dash 1,2. S dash 2,2. S dash 3,2. S dash 0,3. S dash 1 comma 3 S dash 2 comma 3 S dash 3 comma 3. ये सब मुझे लिखना जरूरी है because I will be able to explain you how the shift is happening, how the shifts are happening. Okay, how the shifts are happening. I am going to rub this upper side. Now this is the input. This is called as a state array called as S dash. This is given input to the shift rows. We'll see how the shifts are getting changed. How the bits are getting changed. How the bits are getting changed. Now you understood. This is my 0th row. This is my row number 1. This is my row number 2, and this is row number 3. Okay. So row number 0, row number 1, row number 2, row number 3. So whatever the bit shift are there, that is happening on the rows. That is happening on the rows. Okay, that is happening on the rows. We'll see how. Row 0, as far as row 0 is concerned, there is no shift. No shift. There is no shift of the bits. You can write down along with me. As far as row 0 is concerned, there is no shift, no operation, no shifting operation. As far as row 1 is concerned, there is 3 bits of circular right shift. There is 3 bits of circular right shift. 3 bits of circular right shift. वो कैसे 3 bits है? I will explain you. Just first write down. As far as row 1 is concerned, 3 bits of circular right shift. Then write down as far as row 2 is concerned. There is 2 bits of circular right shift. And as far as row 3 is concerned, you have 1 bit of circular right shift. 1 bit of circular right shift. You have 1 bit of circular right shift. Okay. You have 1 bit of circular right shift. अब इसका मतलब क्या है? See here. इसका मतलब क्या है? ये आपने लिख लिया. Okay. Now as far as row 0 is concerned, there is no shift. Okay. So this row 0 will remain as it is. It will remain as it is. We'll go to the row number 1. Row number 1, I have told you 3 bits of circular right shift. Now what is that 3 bits of circular right shift? You can just write down the heading as 3 bits of circular right shift, and please draw this diagram. Draw this figure. 1, 2, 3, 4. And see the 3 bits of circular shift. See the 3 bits of circular shift. This will be at this position. This will be at this position. This will be at this position. Okay. And this will be at this position. This will be at this position. Okay. 3 bits of circular shift. This is happening where? This is happening at row number 1. This is happening at row number 1. So can any one of you tell me, okay, by using this circular 3 bits of circular right shift, 3 bits of circular right shift. Okay, 3 bits of circular right shift. Now this one, or we'll start from here. Okay, so right shifted. Okay, so this will move at this position. This will move at this position. So this position will become S dash 1 comma 3. 1 comma 3. What will happen to S dash 1 comma 0? This will be shifted here. This will be shifted here. Oh wait, something I have gone wrong. This is your 3 bits of shift, na? This is wrong. 3 bits of shift ऐसे नहीं आएगा. 3 bits of shift ऐसा आएगा. Please make the correction, all of you. 3 bits of shift will not be in this manner. 3 bits of shift will be in this manner. Yes, this will be here. This will be shifted here. Okay, and this will be shifted at this location. This will be shifted at this location, and this will be shifted at this location. Now it is right. Now it is right. This is 3 bit of shift. 3 bits of shift. ये आपका ये जो है 3 bit circular right shift. So 1, 2 and 3 ये पोजीशन होंगी यहाँ पे. इसका क्या होगा? इसका भी वही 1, 2, 3. Okay, so it is 1, 2 and 3. तो ये होगा यहाँ पे. इसका क्या होगा? ये होगा यहाँ पे. और इसका क्या होगा? ये होगा यहाँ पे. Okay, so please make the corrections, all of you. This is a 3 bit of circular right shift, and this is how the shift will happen. 3 bit shift. For example, this is happening at row number 1. S dash 1 0 will be shifted here. So this particular cell will become S dash 1 comma 0. Okay. What will happen to this S dash 1 comma 3? This will be shifted here. What will happen to S dash 1 comma 2? This will be shifted here. And what will happen to S dash 1 comma 1? This will be shifted here. So this is happening at row number 1. This is happening at row number 1. Write down the second one. ये सब मैं सिखाने के बाद you have to draw the result of the row shift or shift row, and that is also called as intermediate result, or that is also called as a state array. That is also called as a state array. Okay. So ये जो मैंने diagram बनाया था, that is for 3-bit shift. Now we'll see what will happen to the row number 2. Now row number 2, that is the 2 bits of shift. So 2 bits of shift. Again, write down the heading as 2 bits of circular shift and draw this figure. And 2 bits of shift will be how? It will be, this bit will be shifted here. This bit will be shifted here. Okay. And this bit will be shifted here. And this bit will be shifted here. So see here now row number 2. See the row number 2. S dash 2 comma 0 का क्या होगा? That will be shifted here. What will happen to S dash 2 comma 1? This will be shifted here. Okay. Then what will happen to S dash 2 comma 3? That will be shifted here. And what will happen to S dash 2 comma 2? This will be shifted here. So this is happening at row number 2. This is happening at row number 2. Okay. And the last one, that is row 3. Row 3, that is 1 bit of shift. And the figure to explain that 1 bit of shift is this one. जो मैंने सबसे पहले बनाया था. This will be shifted here. Okay. And this will be shifted here. This will be shifted here. And this will be shifted here. This is called as 1 bit of circular right shift. 1 bit of circular right shift. Okay. And this will be applicable where? This will be applicable to the last row. That is row 3. That is row 3. So with this, all the shifts of 0 का no shift, इसलिए h dash 0 comma 0 यहाँ पे ही रहेगा. h dash 0 comma 1 यहाँ पे ही रहेगा. h dash 0 comma 2 यहाँ पे ही रहेगा. h dash 0 comma 3 यहाँ पे रहेगा. Okay. So this is how it is happening. This is how it is happening. Okay. So can you draw the resultant now? Can you draw the resultant?
Excuse me, sir.
हाँ.
सर 3 बिट शिफ्ट में भी फिर जो एक एक एलिमेंट है वो 3 बिट्स तक शिफ्ट होना चाहिए ना, जैसे 2 बिट्स में 2 शिफ्ट हो रहा है.
हाँ ना. तो 3 बिट में आप देखो ना, 3 बिट में देखो, आपको 3 बिट शिफ्ट ही समझ में आएगा. दैट इज अ 3 बिट शिफ्ट. दिखने को 1 बिट शिफ्ट लग रहा है वो, बट इट इज एक्चुअली 3 बिट शिफ्ट. देखो कैसे आपका ये बीट शिफ्ट होगा यहाँ से यहाँ पे. तो 1 2 3 3 शिफ्ट हो गया. ओके. नाउ व्हाट विल हैपन टू दिस? दिस विल शिफ्टेड टुवर्ड्स द थर्ड पोजीशन. सो इट विल बी, अब ये जाएगा यहाँ पे. सो इट इज 1 2 and 3. तो मैं ऐसे ही बनाऊंगा ना. अब ये कहा जाएगा, हाँ ये कहाँ पे जाएगा? 3 बार. सो 1 2 and 3. तो मैं ऐसे ही करूंगा ना. और ये होगा यहाँ पे. दिखने के लिए 1 बिट शिफ्ट लग रहा है वो, बट एक्चुअली इट इज 3 बिट्स घूम के जा रहा है. आई होप यू हैव अंडरस्टूड.
ओके सर.
हाँ. So after understanding this, can you complete the resultant one? So again it will be 4 by 4. It will be 4 by 4. It will be 4 by 4. Okay. I will show you for this last one. Remaining you have to do for the for every cell. Okay. So I will just show you for this row number 3. Row number 3. Row number 3. So it is only 1 bit of shift. So S3 comma 0 will come here. So it is S dash 3 comma 0. So this is S dash 3 comma 1. This is S dash 3 comma 2. And this will be S dash 3 comma 3. I have only shown for last row, row number 3. You have to do for row 1, row 2. And row 0 will be the same. No change. So it will be the same. So I hope you have understood this, so that we can proceed further. Okay. So you can complete each and every part. This is called as shift row transportation. This is called as shift row transportation. Shift row transportation. Okay. So 128 bits input and 128 bits output of what? Of shift row. Of shift row. Okay. So can I say now this becomes the input to the next block? What is the next block? That is mixed column. And what we have written for the mixed column? We have written in the bracket, that is multiply with the predefined matrix of 4 by 4. Multiply with the predefined matrix of 4 by 4. Okay, you please refer the previous block diagram. You will understand. Mixed column bracket में हमने लिखा था. Now we are going to understand what is going to happen in the mixed column now. Once if you have understood this, shall I rub this and write down the heading as mixed column. Write down the heading as mixed column. Mixed column. Mixed column. Now we'll see what is happening in the mixed column. Now whatever you have drawn here, that becomes the input to the mixed column. Okay, now I'm not going to write down the notation of each and every cell. मैं just बनाता हूँ क्या? मैं just बनाता हूँ 16 cells. Now this is the input. This is the input. Now we have to multiply by the predefined matrix. We have to multiply by the predefined matrix. We have to multiply by the predefined matrix. And the predefined matrix is ये एक लेफ्ट साइड में ये बनाओ. उसके बाद write down the predefined matrix, and the predefined matrix is 2 3 1 1 1 2 3 1 1 1 2 3 and 3 1 1 2 3 1 1 2 3 1 1 2. So this is predefined matrix of the size of 4 by 4. Of the size of 4 by 4. Now this one has to multiply with this. This one has to multiply with this. Okay. So you know this is 4 by 4 and this is your 4 by 4. Actually multiplication कैसा होगा? Your first ये होने के बाद you please draw in this manner. This first column will be multiplied by with this matrix. Okay, this first column will be multiplied by this matrix. Okay, so I'm writing, I'm doing it here.
प्रियंका मैम, आई?
हाँ बोलो।
हाँ, सर ने आपको अटेंडेंस लेने के लिए बोला है।
हाँ लिया मैंने अटेंडेंस।
ओके। एंड गाइस, सर ने बोला है कि 3:20 के बाद ही विल बी टेकिंग हाफ एन आवर लेक्चर। सो बस आज का पोर्शन खत्म करने के लिए। सो आफ्टर 3:20 देयर बी अ हाफ एन आवर लेक्चर ऑफ DCE। सॉरी। कूल विद एवरीवन?
यस, मेरे बिजनेस कॉल्स है।
हाँ ठीक है।
कूल कूल। अभी हम लोग मीटिंग छोड़े क्या?
शुभम,
फोन पे है।
जानवी, हम लोग मीटिंग छोड़ सकते हैं क्या?
एक मिनट रुको, शायद वो सर से बात कर रहे हैं।
विल बी कमिंग राइट नाउ। अगर पोर्शन अभी खत्म हो जाता है तो 3:20 के बाद कोई लेक्चर नहीं होगा। फिर अभी
7
देखते हैं।
मिनट्स
सर
है
इज
ब्रो।
कमिंग राइट।
7 मिनट में 30 मिनट का लेक्चर।
अरे अटेंडेंस ले चुके हैं ना मैम?
अरे अविनाश,
हाँ ले लिया अभी।
और वो छोड़ चुकी है ना रूम?
अरे ओ, थोड़ा चेक कर ले।
रिकॉर्ड हो रहा है वैसे।
मीटिंग रिकॉर्ड हो रहा है गाइस।
तो ऑफेंसिव काम बोला है कुछ, मतलब बस कुछ फैक्ट्स रखा है ना सामने, अब वो तुम्हारे ऊपर कैसे लेना है?
थैंक यू समीर, थैंक यू फॉर सेविंग आवर लाइव्स। थैंक यू समीर। समीर दबंग।
समीर द ओनली वन।
समीर दबंग।
दबंग दबंग।
तू इलेक्शंस में खड़ा हो रहा है कि नहीं? वो गर्ल्स
क्या बोल रहा है? हाँ ब्रो, मैं ई सेल इंचार्ज बनेगा।
समीर को समीर
मेरा स्पॉट चेंज मत अक्षर।
समीर, सॉरी सॉरी। समीर तो जीएस जा रहा है ना अगले साल।
समीर का बस टीम बन जाए। क्या है समीर
भाई वो देसी बहुत देखी है, पीछे गाना बजेगा, समीर ऐसे एंट्री करेगा शॉर्ट खोल के जीएस वाली।
किल मी, प्लीज किल मी।
बस कर दे भाई, बस कर दे।
कभी है फिर इलेक्शंस के लिए? कभी आ रहा है गूगल फॉर्म?
आज एमपीआई के लेक्चर में आएगा ना।
समीर तो
चलो
बाहर
सब लोग अपना अपना स्पीच दे दो, इधर ही वोट मांग लो।
गाइस मुझे वोट दो प्लीज, थैंक यू।
एमपीआई के लेक्चर में करो ना ये सब।
नाइस।
सब जगह पावर कट नहीं है मुझे।
सब यूट्यूब पे जाएगा।
थर्ड लेक्चर है सौरभ, थर्ड लेक्चर है।
पावर कट हो गया तो
सब जगह थोड़ी ना पावर कट है भाई।
हो गया तो जस्ट इमेजिन।
भाई एक सेकंड, तू हमारे पत्ते क्यों काट रहा है? जिन्हें
अरे अक्षय तू बनेगा भाई, तू क्या इतना वो कर रहा है?
थोड़ा मेरे को टेंशन लेने में मजा आ रहा है, लेने देना। ओह सर आ गए।
Am I audible now?
यस सर, यूर ऑडिबल।
यस सर।
ठीक है। हाँ, ये अभी फिर से ऐड कर जाने के पहले मैं ना क्या करता हूँ, आई विल कंप्लीट दिस सो दैट इन द नेक्स्ट लेक्चर आई कैन स्टार्ट विद द नेक्स्ट टॉपिक, दैट इज नेक्स्ट मॉड्यूल। ओके, सो आई विल हार्डली टेक 10 minutes टू कंप्लीट दिस। इज इट ओके फॉर यू? सब लोग है ना?
यस सर।
Okay. Yes, here now. This is your this is the output of the S block. This is the output of the S block. This is given to the mixed column. Mixed column, I have told you we have to multiply by the predefined matrix. I have written the predefined matrix here. Now, how the multiplication is taking place? This first column will be multiplied by this matrix. So this first column I am writing it down here. लेकिन मैंने जैसा कुछ लिखा नहीं तो ये भी मैं blank छोड़ता हूँ, ये भी मैं blank छोड़ता हूँ. So when you multiply this again, can any one of you tell me now what is the size of this column? Sorry, this particular row. Can I say it is 4/1? It is 4/4. What is the size of this matrix? It is 4/4. What is the size of this one? That is 4 by 1. Then the output of this is again 4 by 1. The output of this is again 4 by 1. Okay. So if you do the multiplication of this, you will get this particular 4 by 1 matrix. Now this 4 by 1 matrix, this whatever 4 by 1 matrix is generated, this will be placed where? This will be placed where I am drawing here. This is also 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. Now this will be substituted here. Ye pura substituted will be here. Now if I am taking the second one, please draw. All of you draw in this manner. Now if you take the second column, multiply by this. So this second column will be placed here. When you multiply, the answer will be again 4 by 1 matrix. Now this 4 by matrix will be placed where? It will be placed here. Again you take the third column, multiply with the predefined matrix. Whatever the output you get, that is 4 by 1, will be placed where? Will be placed here. And the last one, the last column, when it is multiplied by the predefined matrix of 4 by 4. Okay. So that this particular column size is 4 by 1. So when you multiply 4 by 4 with 4 by 1, then you get 4 by 1 matrix. Okay. And this will be placed here. It will be placed here. Okay. So you have got the resultant matrix. You have got the resultant matrix. Again, it is intermediate, no output. This is again the intermediate. So you can say this is a mixed column output matrix. This is a mixed column output matrix. This is a mixed column output matrix. Okay. I'm repeating once again. This process is called as mixed column transformation. आप यहाँ पे लिख सकते हो as a heading as mixed column transformation. Mixed column transformation. Okay. So mixed column transformation से आगे मैं बता रहा हूँ, पहला column multiply by with this and substitute at this level or replace at this first column. Take the second column, multiply by the predefined matrix, place at the second column. Take the third column, multiply by the predefined matrix, place at the third column. Last column, multiply by the predefined matrix and place at the last column. So this is how it is happening in the mixed column transformation. Mixed column transformation. Again, this is predefined. We as a user will not have the access to change the bits. ये ऐसे के ऐसे ही अपने को लेना है और उसको multiply करना है हर एक column के साथ. And the final is the mixed column output matrix. Now this is the input to the mixed column and this is the output of the mixed column. Now this output of the mixed column will be given to where? It will be given to the add round key. Will be given to the add round key. Okay, will be given to the add round key. So please write down the heading as, all of you write down the heading as. Do you have any doubt in this? Shall I rub?
So your voice is breaking, sir.
Okay. Okay, now it is okay. Now it is okay?
Yes, sir.
Okay. If you have any doubt, please ask me. I'm going to rub this so that we can go with the last block, that is add round key. Shall I rub this? Now the final one, that is add round key. Add round key. This is the final one, add round key. And what you have written in the bracket? You have written for this as XOR operation. We are doing the XOR operation. Okay, we do the XOR operation. That is performing XOR operation with the state array, which is output from the mixed column. So can I say this is the output of the mixed column? This is output of the mixed column. This is getting XORed. This is getting XORed with the key. Okay, with the key. And tell me the size of key. That is also 4 words. So can I draw the 4 words here? 4 words. as far as your round 1 is concerned, okay, your 4 words are W4, W5, W6 and W7. So can I say this is my key one? This is my key one. Now suppose you have a key that is a pre-calculation before I use the round, that is K0. So can I say the same thing is applied, but here it will be K0, here it will be K0. Okay, in that case it will be W0, W1, W2 and W3. But in that case, what is this? This is your plain text of 128 bits. Yes or no? Someone of you please acknowledge. If I am taking K, yes, if I'm taking K0 as the key, words are W0, W1, W2, W3, and it is getting XORed with a plain text which is a size of 128 bits. Okay, as I'm talking about the round 1, round 2 and round 3, okay, I will consider here as round 1. In that case I will consider this as key K1, and this will be become K4, K5, K6 and K7 and the K7. Okay, and when you do the multiplication or XOR operation, that is XOR operation, not multiplication, XOR operation, here you will get the final output. This is again 1, 2, 3, 4, 1, 2, 3, 4. Okay, and this is your resultant state array. 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 Okay, so this is the output of the mixed column getting XORed with the key. As per the round, you will have the key. For first round it is K1. For the 10th round it is K10. Okay, and in that K10 you know what are the respective words. ये हमने पहले भी लिखा है. Okay, so this is not new to you. And when you XOR, when you do the XORing, you will have the resultant state array. You will have the resultant state array. Okay, you will have the resultant state array. I will take more 2 minutes now. Now you know, as far as the round 1, round 2, round 3 is concerned, as far as round 1, round 2, till round 9 is concerned, you have add round key with the corresponding key number, okay, but I have told you for the 10th round, okay, there are only 3 processes. There is no mixed column operation. So there is no mixed column operation. So directly the shift rows will be given to the add round key. Directly the output of the shift rows will be given as the input to the add round key, and the key which will be used in that round 10 will be K10. Okay, and the key and the words would be W40, W41, W43, 42 and W43. Okay, so in such we'll be using all the words, total keywords, that is 44 words. Total 44 words will be used for the total 10 rounds. And this is about the last add round key. Okay, so here we have ended with what? Advanced encryption standard. Do not forget, 100% the questions are asked on this, about the advanced encryption standard or data encryption standard. Okay, so with this we have completed with the second module. In the next lecture, not second module, the data security, the topic data security we have completed. In the next lecture I will be talking about asymmetrical encryption, AES and DES. As far as AES and DES is concerned, this will come under the symmetric encryption. Now the next we should talk about asymmetric encryption algorithm. And in the asymmetric encryption algorithm, as we have AES and DES, for symmetrical one we have RSA. Okay, so in the next lecture we'll start with the new topic, new module. Okay, and we'll start with the RSA, because this is the algorithm which is used for the asymmetrical encryption algorithm. Okay, RSA. Okay, so we'll stop here. If you have any questions, please ask.